Hello friends, I welcome you in lecture number 15 on complex integration. In this lecture we will discuss one more problem on complex integral. This question was asked in GTU summer 2021 examination. So let's try to evaluate this complex integral. Here given function is e raised to z over 1 minus z square and this contour C is mod z equal to 1 half, and in second case it is mod z minus 1 equal to 1 by 2. So we have to evaluate this integral along these two different contours or different paths. So first we try to evaluate this complex integral along first contour, which is mod z equal to 1 by 2. So here first we write that in first part given contour is mod z equal to 1 half, that is it is a circle with center 0 and 1 by 2, and our function is e raised to z divided by 1 minus z whole square. This is given function e raised to z divided by 1 minus z square. Now we know that this e raised to z is analytic everywhere. This 1 minus z square is also analytic everywhere. So division of these two will be analytic everywhere except those points at which denominator becomes 0. So this function will fail to analytic for those values of z for which 1 minus z square is 0. Now this is going to be 0 if z equal to 1. So given function is analytic everywhere except z equal to 1. So we can say that, or we can write that e raised to z over 1 minus z whole square is analytic everywhere except z equal to 1. Now given contour is mod z equal to 1 by 2, that is it is a circle with center 0 and radius 1 half. Suppose approximately this is this circle with center 0 and radius 1 by 2. So if this distance is 1 by 2, 1 will be somewhere here, and our function is not analytic at z equal to 1, and we can see that this z equal to 1 lies outside this circle mod z equal to 1 by 2. So that means we can say that this function e raised to z over 1 minus z square is analytic everywhere inside and on this simple closed contour mod z equal to 1 by 2, because z equal to 1 lies outside this contour. So we can say that this function is analytic everywhere inside and on this contour C, which is circle with center 0 and radius 1 by 2. So we know that if our function is analytic everywhere inside and on a simple closed contour, then by Cauchy-Ursaert theorem value of integral of that function is always 0. If function is analytic everywhere inside and on a simple closed contour C, then integral of that function is always 0 by Cauchy-Ursaert theorem. So integral of given function is 0 along first contour mod z equal to 1 by 2. Now we try to evaluate integral along this circle mod z minus 1 equal to 1 by 2. So that we write here in second part given contour is circle with center 1 and radius 1 by 2, and our function e raised to z over 1 minus z square, this is analytic everywhere except z equal to 1, and we can see that center of this circle is z equal to 1. So z equal to 1 lies inside this circle. So here we have to think for Cauchy integral formula. Okay, here we can write this. C is this circle with center 1 and radius 1/2. Okay, we can sketch also. Suppose this is this distance is 1 and radius is 1/2, so we can approximately visualize this circle in this way. It is circle with center 0 and radius 1/2. So this distance must be 1/2 and this is must be 3/2. So our function is e raised to z over z minus 1 square. It is 1 minus z square, but we can rewrite it as z minus 1 square also. So here at z equal to 1, this function is not analytic, and z equal to 1 is inside this simple closed contour mod z minus 1 equal to 1/2. So here we cannot apply Cauchy-Ursaert theorem because this function is not analytic at z equal to 1, which is inside this contour. So here we must try to apply Cauchy integral formula. Now as we know, Cauchy integral formula is applicable for this type of integrals: f of z divided by z minus z0 to the power n plus 1 dz, where this f of z is analytic everywhere inside and on simple closed contour C, and z0 lies inside that contour. So here we can compare our function e raised to z over 1 minus z square or z minus 1 square with this. So if we consider f of z equal to e raised to z, then e raised to z is entire function. Therefore it is analytic everywhere inside and on this simple closed contour C. And we know that this z equal to 1 lies inside this contour C. So here we can apply Cauchy integral formula by taking f of z equal to e raised to z, and we know that this is nothing but 2 pi I divided by n factorial, and value of nth derivative of this function at point z. So this is going to be, here we have 2, so if we compare 2 with n plus 1, n will be equal to 1. So this is going to be 2 pi I divided by 1 factorial and first derivative of e raised to z at z equal to 1. So this second part can be done using extended version of Cauchy integral formula. So first we have to write appropriately that we consider f of z equal to e raised to z, and we mention that e raised to z is entire function, so clearly it is analytic everywhere. Clearly e raised to z is analytic everywhere inside and on given contour, which is mod z equal to mod z minus 1 equal to 1/2. And what we require, another thing, is 1 lies inside C. So therefore by Cauchy integral formula, we can see that f of z, our function was e raised to z over 1 minus z square, and 1 minus z square can be rewritten as z minus 1 square. So here f of z is e raised to z. So this is going to be by Cauchy integral formula 2 pi I divided by 1 factorial first derivative of f at this point, which is 1 here. Now f of z is e raised to z. So derivative of e raised to z, as we know, it is e raised to z itself. So here we put z equal to 1 and we obtain e raised to 1. So finally we obtain 2 pi e times I. So this is the value of integral of e raised to z over 1 minus z square along contour mod z minus 1 equal to 1 by 2. It is 2 pi e times I. So these are very easy questions on complex integrals which were asked in past year GTU exams. So I hope you like this. Thank you very much.